individually and spreading malware. The malware is already there for you. All you have to do, all you have to know is how to speak the right protocol, or what system to talk to, or what web query to literally punch into the URL bar in your browser to go and take over all those machines. So here's a fun attack vector. Basically, the purpose of these systems is for admins to pull information out of 10,000 agents running on these machines. The information coming out of those agents is trusted. It is the original source for all knowledge of what's happening in the network. When an agent reports its operating system as this particular version of XP, SP2, whatever, everything's trusting that. And if the agent reports that its particular version of Microsoft Windows XP is JavaScript alert high, somebody's going to see that information at some point. And if it's a browser-based interface, well, the trusted source of all the information can include all sorts of crap. It can include JavaScript, it can include SQL, which will often break things on the server itself. If you just put things in, it'll break SQL queries. Again, the information that the agents generate is trusted, both at the server and in the actual clients that are communicating with the server, in the Windows web management interface and in the browser interface. You can put JavaScript in the responses that an agent gets, and you can take over the browser of the guy who uses the web-based management interface for the agent-based management system. The problem with that is that that is a particularly valuable browser to own. Not only is that the guy who directly, overtly owns 10,000 machines network-wide, but he's also obviously a highly trusted IT admin, and you have his browser completely at that point because you were in control of the information coming out of the agents.
Well, and not only that, right? You're also talking about being able to, at that point, inject JavaScript into someone who is clearly at and has already logged into the management application. So it's not going to be too big of a step to write some JavaScript that's going to submit a URL to that and start executing commands to the management server just right through some simple JavaScript.
Because we got a little bit scrambled here, I want to make sure that we make a point that I don't think I've made yet. The number 10,000, for instance, is a meaningful number from a security perspective, that order of magnitude. If you want to start attacking these systems, if you want to come up with a scenario in which you end up owning 10,000 machines, you don't have to start with a Stack Overflow and the connection setup message to an agent. You can take over any one of those 10,000 agents with any attack. It could be a bad password, it could be an open share, it could be any possible attack that's going to get you local admin on a box running that agent. At that point, you're in a position to talk to the management server, and you're in a position to source information that's going to flow through the rest of the system and hit people in a variety of different ways. You can't possibly trust that any group of 10,000 systems on an internal network today is actually going to be secure. But that's exactly what these systems demand that you do. Because every one of them is trusted in exactly the same way to report the truth, or at least report information that isn't going to break the rest of the system.
Well, and it's also, I think Tom hit on this earlier, it's not just 10,000 hosts, right? You're talking about that's for each agent that is installed, each management system that's installed. And anyone here that works for a large organization, when your machine's loading up, you're not seeing one of these, you're seeing 5, you're seeing 6 of these get loaded up. So there's a lot of avenues of attack to go after different groups of machines, and just, you know, the breadth and depth of this problem is tremendous.
So we've talked a little bit about, and I've been cryptic and I apologize, about the ability to take, you know, a management application from, say, I don't know, I almost did it. But we've talked about being able to send malformed connection messages to an agent, or send a malformed connection message to a server. You know, what about the fact that there's a Win32 management client talking to that server? Well, what's running in between that Win32 management client and the server itself? Well, it's not what you might expect. It's not like, you know, on the back end, just XML RPC requests or something like that. No, it's some crazy, ridiculous, funky binary RPC protocol that these people invented themselves. So when I say these people, I mean all of them. Every single Windows management application that we've seen has some crazy new binary protocol, always built around RPC. Not every one of them, but always built around some kind of RPC concept. For instance, these people will take strings out of packets and they'll do Java, you know, look up the class by its name and then call a method by its name. Ridiculous things that are trivially easy to break. So essentially we can repeat all the same attacks that we did before, but the important thing to remember here is that we're talking about a different set of protocols in the exact same system. These aren't the same attacks. every one of the attacks that we talk about, you can usually multiply across every single connection in the system. So we have vulnerabilities where you can break the RPC protocol, for instance, that runs in between the Win32 management client and the management server. And the thing that you have to remember is that there is a different protocol, usually running on a different port for that particular connection, and it has to be secured separately. You have to look at it separately. You have to make sure that only the legitimate people, IP speakers, can speak that. Whatever you can do to lock that down. In a perfect world, what you'd be doing is you'd be doing TLS with client certificates, so that you can't possibly talk to the management server unless you're holding a certificate that proves that you're allowed to talk to that. But almost none of these applications even offer you the possibility of doing that. It's funny, even when they do offer that, the IT people who are installing these applications certainly aren't setting this up. Provisioning certificates to every one of them, everybody using a particular Windows management application, never going to happen. In iSCSI, you authenticate yourself by asking for a particular, they're called LUNs, and they have target names, right? But you ask for a particular set of disk with a particular name. And the protocol, authentication of the protocol is essentially optional. You have to turn it on. It's chat-based authentication. And we found this vulnerability, and we're jumping up and down like, we can bypass chat on these things. It's like, well, that's great, but none of our filers even run chat. They're all running just completely open. It's the exact same situation with a lot of these management applications. Security is almost always optional. Vendors certainly do have the mindset that these things are running behind your firewalls, and therefore they don't have to, concern themselves with it. So certainly look at the documentation. Any optional security feature is off if the IT people set it up, because all these security features add headaches for the IT people setting it up. How are we doing at time?
We've got about 10 minutes before we have to start letting people ask questions.
Let's do this one really quickly, because I'm particularly fond of this. I don't know how many of you guys are familiar with Corba, but
One guy raised his hand over there.
Corba is an object-based or an object-oriented RPC protocol. And Corba is the future if you live in 1996. And you guys are laughing, right? On a different version of this slide, we have the list of all the people who are publicly running Corba. Corba is running in places that you've never heard of before on these custom IT projects. There are vendors that use Corba as well, and Corba is totally broken. It's also not that hard to understand, and this slide again is messed up, but I think I can talk through it pretty quickly. You can map Corba to web pretty simply. And if you know how to attack a web application, and pretty much everyone knows how to bust web applications at this point, the exact same concepts apply. So Corba has a binary protocol called IIOP. And it is the worst binary protocol ever invented. It's awful. It's just a hideous, horrible protocol. But it's documented, and there are public IIOP clients. IIOP is the total moral equivalent of HTTP. It does precisely the same thing. Corba has Corba messages that are sent to objects. A Corba message is an HTTP post request. It is the moral equivalent of an HTTP post request. It does exactly the same thing. Corba has what's called orbs. Orbs are one of the scary sounding things in Corba, but a Corba orb is simply the Corba equivalent of a web server. It's the thing that actually takes the messages in and sends them to the right instance that owns the object. Corba has objects. Objects in Corba are the exact same thing as web pages, as a page in a PHP application. A Corba object is a PHP page in an application. Corba has IOR. IOR is the Corba way of spelling URL. They're literally strings that refer to objects and arguments to those objects. On the web, we have DNS. Corba, for some reason, has its own naming system. It's called COS naming, and we're going to get to that in a second. And there's a variety of problems with that as well. Corba has methods. Methods are the moral equivalent of the arguments you tack on to a request to a PHP page. Corba has service context. Service context is a long way of saying cookie. Serves exactly the same purpose, works exactly the same way in a binary protocol, but is exactly the same idea as an HTTP cookie. And then Corba has a message body, and posts have post arguments. The point here is that all the attacks that you use to break a web application, putting meta characters in trying SQL injection, trying to go directly, this is this works everywhere, right? If you have a Corba application that's authenticated, you have to talk to an authentication object before you access anything else in the system. Well, just like in old web applications or internal web applications where there's an authentication page, but that's essentially cosmetic because you can just skip it, exact same thing applies. If you scan all the orbs in a Corba system, some of them won't check your authentication. You can talk to them absolutely, you can talk to them directly. All the same attacks that work from OWASP work in Corba apps. Of course, the slide isn't going to have labels, so I'm just going to speak to it, but it's an excellent attack. So, well, like I said before, Corba has its own name service. When you bring a new object up, that object has a name, and the guy who owns the object determines what the name is. It's like dynamic DNS, except that it's dynamic DNS without any authentication. Without their dynamic DNS, without the COS naming service, none of Corba works. These Corba names are how people find other objects. So for instance, you have an authentication object that accepts messages, and if the messages prove that you are a specific user, they'll spit back a cookie back to you that you can use for other objects to prove that you've actually logged in. Well, that authentication object has a name. And the fun part about this is the orbs themselves that run the name service and the objects that implement the name service aren't authenticated. You can literally rebind the Corba names. You can forward all requests to the authentication objects to other objects, to you. You can man in the middle them if you want to. You can sniff all the actual authentication going through them. It's trivial, and it's part of the protocol in Corba. There's no authentication to the name service in Corba. So we've very successfully used this to break a particular Corba backend for a Win32 client talking to a management interface where somebody on that dev team thought, Corba is the wave of the future and we better, ride that wave. So we're able to go and take the authentication object or any other object in the system and hijack it or park the name for it and then man in the middle proxy it. And authenticate ourselves anywhere. And again, what we're going to do here is we're going to implement a plugboard proxy that's going to run their standard Win32 management interface through our proxy transparently and give that proxy the ability to run as an arbitrary user and run without passwords. So this is a protocol level problem with Corba, and it's par for the course for internal RPC protocols.
Well, and I think it's also, this is another thing that it didn't take a lot of time to come up with this attack because people have already done this. This exact type of vulnerability existed inside of SunRPC again in the early to mid 90s and was used in almost the exact same way that we're using it today against an internal application.
The only thing that took a long time to find that vulnerability was actually realizing that could possibly be there. So you don't even bother to read the specs for the name service because it can't possibly be that you can just unplug anybody's name and plug it back into you, but it totally works. So agents talking directly to the clients, the Win32 clients, I said before that for the browser interface for these things, you can put JavaScript in them. If you want to try and corrupt the server with agent responses, you can put SQL in them. If you want to try and attack the Win32 client interface for these things, well, you generate really long strings. This is straight up Win32 code compiled without the GS flags or any of the compiler security by people who never, ever, ever thought about security. These are people who are plugging dialog boxes in Visual C, and that's hard work and all that, but it has nothing to do with securing software. So the simplest conceivable things, if an agent spits out an overly long string, you can take over the Win32 client. It's just like taking over the browser of the IT administrator that's running the application. We talked a little bit before, and we talked way too fast about the command and control interfaces in bots and the middleware implementations that allow the servers to talk to the tens of thousands of, and there's a variety of message-oriented middleware protocols that people use. An example that I'm not specifically talking about here would be something like Tibco Rendezvous. It's an example of a message-oriented middleware protocol. Tibco has other message-oriented middleware protocols as well. Now, one interesting thing about the message-oriented middleware protocols that connect the servers to the tens of thousands of clients is that they're a lot more sophisticated than IRC. You can do a lot more things with them. So they're a little bit more fun to play with, and they're absolutely just sitting there waiting to be a command and control interface for all the systems running the agents on the network. The other thing about these is that they're documented pretty well because they're sold.